Hello coders, welcome to episode 154 of the How to Code Well podcast. Today we're going to be talking about continual integration, and I have 10 tips for people who are interested in building their continual integration pipelines. Now, before we start, I am not live, as you can probably tell. This is a pre-recorded show because on Thursday I am giving a talk on PHP Stan, coding with confidence using PHP Stan at PHP UG MN, that is the user group. And I'll leave links in the show notes below, of course, to that talk. So, a bit of the changelog. Let's get into that before we get into the continual integration. So on Sunday, we rebuilt the first 5 lessons of the PHP logging course. When I say rebuilt, what I mean is that we're on the final phase of going through the documentation, making sure everything works as it says it should work on the documentation side. We've done the first 5 courses, 5 tutorials, 5 lessons. And what we're going to do on Monday, not Sunday, Monday on Twitch is go through the final 4, hopefully. And we've also started the next course. So the another course coming up, which is the PHP registration course. We started that on Tuesday on YouTube. So that was 6 p.m. on Tuesday on the live stream. The reason why I've got 2 courses going at the same time is there needs to be a bit of overlap because I haven't done any recording of the PHP logging course. I was ill and other things has happened. I've been very busy. Plus, we still are doing the final phase. So once that's done, I can then start recording. I also want to get some more or some better equipment to record that course as well. So that's something that I'm investigating. And the PHP registration course, that course is going to take quite a long time to produce or plan, build, develop, record anyway. So, these are long-term how to code well strategies that I'm doing here. And that course, just to give you a little bit of context, will teach PHP without any frameworks, and it's going to teach PDO, and it's going to teach HTML. It's going to teach how to register a user to a database, so how to insert records, select records, how to use a form to register a user, how to log in with that registered user, and then how to update a user's record through a profile screen, a secure profile screen that you can only get to once you've registered. So there's quite a lot of things that the course will teach. And of course, it's going to have good practice. We're going to go through a little bit of TDD, a little bit of PHP Unit, PHP Stan, and other tools as well. And I'll be talking about input sanitization, data validation, and all that good stuff. So that's what we're going to be doing on the Tuesday shows throughout. Okay, so let's get on to the show, which is continual integration. And the reason why we are talking about continual integration today is because on the last podcast, I mentioned that I would like to purchase perhaps a service that helps with continual integration when we were talking about the self-hosted services versus the managed services. And I have my eye on a couple of these things specifically for continual integration. And I realized after the show that I haven't really explained what that is, continual integration. And so what I've got here is kind of a rundown of what that is. I have 10 tips for continual integration, 10 rules, if you like, of continual integration. And then I have the way in which I am currently using that at the moment. Okay, so what is continual integration? Let's start with that. It's essentially you building a pipeline that allows you to commit your code from commit to publication, essentially. Although publication is probably not the right word because that often gets confused with duplication, with delivery, and continual integration isn't continual delivery. You need to have continual integration in order to have continual delivery, of course, but we're not talking about continual delivery today, continual integration is where you are integrating continually into the source code, right? So you create a branch and you write code, and then you merge that branch into the main line, or you get it to a point in which it can be released. So you're not releasing it, you're getting it to the publication stage. So you're making sure that your code works well with the other code that's already on the system, and then everybody else's code that's coming in from their feature branches. So it is essentially the entry point. Continual integration is the entry point into the development space, right? So you've got this pipeline. This is the entry point. So you start by committing your code, and then that goes into the pipeline. The pipeline does a series of tests, tells you whether or not it can be integrated well. It then either performs the integration and gets it to a release candidate stage. And then at that point, you can look at continual delivery if that's what you wish to do. So it's a publication process. That's what essentially it is. It's you publicizing and sharing knowledge with other teammates. CI, though, it's not about really the tools. And I know that I've said that I'm looking for a service that I can purchase that will help with the CI of how to code well. But it's not, CI is more an idea or a methodology. It's not the tools. So you'll see some tools that are specifically marketed around CI, but there is never one single tool that will just do all the things you need for CI. I've never found that. And there'll be all sorts of tools within the pipeline that get fired off. These are essentially like little gatekeepers that prevent bad code from coming into touching the main branch, or master branch, or the release branch, or however you're building your application, developing it. There's all sorts of different branching strategies, and we're not going to talk about those today, but it's however you're going to get your code from your feature branch, I suppose, from your development stage into the stable branch. Right. And we'll lean a little bit more on how I'm doing it around pull requests and merge requests and stuff, which might make more sense at that stage. But let's talk about the 10 tips. So I've got 10 tips here, and then after that, we'll talk about the ways that I'm implementing this. So number one is that CI, and remember CI is not CD, CI is continual integration, not delivery, so you're not deploying stuff. CI should take no more than about 10 minutes. So from commit to having something that says that it is in a releasable state, it really shouldn't take more than 10 minutes. However, this is a very gray area, shall we say, because what is it that it's doing? Because in every project that I've been in where CI is used, in some cases the tests are more thorough than others, or they require more steps in the CI. It's not just testing, it could be other things like building reports and stuff. So really, ideally, it should take you no more than 10 minutes from commit through to the end of the pipeline. And therefore, reverting any changes back. So if you've broken the pipeline, shouldn't take any more than 10 minutes as well, right? So getting it back to a state where it's where the pipeline is stable, and we'll talk about bad pipelines later on. Excuse me. So how do you do this? How do you get it from how do you keep getting things into the pipeline every in 10-minute cycles, 10-15-minute cycles? Well, essentially ideally what you want to be looking at is TDD. So this is a test-driven development. So what you're doing is you're writing your failing test first, and then you're writing the code that then hits the test, and then your test will tell you whether it's working or not. And then you go through a series of refactoring. And at the point in which the test is green is the point, and you're happy with it, it's the point in which you commit. And that's where you get very nice small commits where you're only committing very small tweaks and changes. So, I mean, this is another point in this. So you want to keep your commits nice and small, and the actual files that you're committing nice and small as well. And you want to be doing this frequently. This is in the ideal space. Of course, we're going to be talking about how I do it in just a second. So point number 3 is to use TDD. Point number 2 is that reverting should take less than 10 minutes. Point number 1 is that your commits, the pipeline should take no more than 10 minutes to complete. Point number 4 is to keep your commits nice and small and simple. And point number 5 is to always monitor the pipeline. You want to monitor the pipeline because you want to be the first person to know that there's a problem with your code. And also you want to keep an eye on everybody else's code going in. So if you're working in a similar area as someone else and they're failing, the code that they're putting into the pipeline is failing, then you want to be aware of that as well. Now, I'm not going to talk about, build sins or anything like that where, team members have to do some penance or something because they've screwed up the pipeline. Things happen. Life happens. I've certainly blown the pipeline up many, many times. And then, and the reverts have often taken more than 10 minutes, sure. But you want to make sure that the pipeline is as stable as possible, because if the pipeline is broken, so if there is something in the pipeline that is failing, it's going to prevent your other team members from using that pipeline, right? Because, if it's stuck, then other people can't do builds. So unless you've got parallel builds or what have you. We're not going to talk about that because that's another layer of the onion, shall we say. Let's say, for example, I'll give you an example. Let's say you're pushing to a staging. So you want to try and get a staging server up to date. And let's say, I mean, I know we shouldn't be talking about continual delivery, but let's say there is continual delivery at the end of this. So when you push to the staging branch, when you do a merge into the staging branch, it goes through a series of checks, the same series of checks plus more that you would have done if you had just committed your code change. If there is a failure in that, then that means that no one else can use staging. And if they pull down the code that's in staging, it's going to have the failure. You see what I mean? So you want to monitor the pipeline. Essentially, getting back to this list, you want to monitor the pipeline. This should be as green as possible for as long as possible, right? So So point number 6 is to don't leave broken builds in the pipeline. So don't just walk away and go, okay, I've just pushed this off to the build pipeline, and now I'm going to go for lunch, or I'm going to go home. Right? It's your responsibility as the committer to monitor the pipeline and to be aware of any bugs that you have introduced into the system because of your failing build. So, well, that's tricky because with a build pipeline, it should prevent you from introducing anything into the mainline. But if you have stopped the build pipeline from going forward, then you have basically held up members of the team, right? So you want to make sure that you can revert those changes back, and you want to do that within I've said here 10 minutes, but 10, 15 minutes in the shortest possible time. All right. This is why your commits should be nice and small and simple, because the bigger the commit, the more difficult it is to revert. Because if you've got code going spanning all sorts of different features, spanning all sorts of different things, different contexts, then it's going to be very difficult for you to identify what is actually failing and cherry pick the thing that is actually the thing that you want to commit or can commit. So again, going back to the point of keeping the commits small. So don't leave broken builds. That's point number 6. Point number 7 is to, and this is super important, is to run the pipeline locally first. So this is where you're running the tests that the pipeline would run locally. This gives you instant feedback. So you don't have to wait for some automated system to pick up your feature branch and run a test. And in some cases, your build may be in a queue, right? So don't rely on the build pipeline to verify your work. You should be verifying your work locally first, and then you offer it up to the build pipeline. Build pipeline, again, is probably not the right term. I keep doing this. I guess, I don't know. People call it build pipelines, CI pipeline. It really depends on how much you float to delivery in this pipeline, to be honest. Now, the pipeline will get to a certain point and then it will go off and do other things if you're doing continual delivery. So you want to make sure that the point in which the integration happens, so, going through the tests that you need to do, can be done locally. So in my case, we have all sorts of tests. I'll talk about them all soon, all the things that I have to do. But also in my experience, there could be reporting that happens as well. Code coverage reporting. There could be PHP documentation being built. There could be all sorts of things, artifacts that get created and produced. Don't worry about any of that stuff locally, really, to be honest, because that can take a bit of time. So don't worry about having to rebuild things. You might want to do that once every so often, but this is mainly talking about the code. So this is continual integration of the code, not the documentation, not the code coverage reports or the whatever fancy HTML reports that are being produced here. This is how you can get your featured code into the main line as quickly as possible. So don't worry too much about all the other things that happen in the actual pipeline in the cloud, for instance, because those things will probably not be relevant to the code that you're doing. They are just artifacts from the build pipeline that get produced at certain times. And again, we'll talk about those things when I talk about how I've been doing them. Okay, so what's this? So number 7 is to run the pipeline locally first, to verify that it works first, because that's your quickest feedback loop, right? Number 8 is to keep your branches up to date. So in my experience, this is not ideal, but in my experiences, branches do have a very long longevity, right? Ideally, you want to have really short branches. So a branch that is only around for a couple of hours or a day tops, but not floating around for days, weeks, or months. This is because they get stale. Branches get stale, and the main line, the master, the main branch, whatever the stable thing is, that's often gone ahead of itself, ahead of yourself, right? So it's advanced since you've created this feature branch. And so you have to continually merge the mainline back in to your feature branch to pick up the changes that the mainline has that you don't have, which means that you now have to do the tests again to ensure that the things that are new aren't actually affecting your work. So this is good practice anyway, to keep yourself updated. You never want to get to a point where you do a PR and the PR is so old and it's so stale that it just has a series of merge conflicts going in because maybe the project's gone in a different direction. So again, leaning on experience, if there is something that is being, if you're working on a feature branch and the feature gets canned, you want to make sure that, and this can happen from time to time with budget issues and the business going in a different direction and whatnot. If that happens, you want to raise a flag and say, well, if this ever does see the light of day, there is a massive risk that the mainline is now going to go on and on and on and on. And the longer this branch is stale, the more things we have to integrate back into this feature branch, so there is a risk. So when things get canned, it's often best to delete the branch or archive the branch and then have some sort of spike going on to say, to investigate how easy it is to revive it, if that is the case. So, okay, that's just a little snippet there. All right, so keep your branches up to date. Number 9 is that failures should be addressed immediately. So going back, I suppose, to point number 2, where reverting changes should take 10 minutes. If there is a problem with the pipeline, then you should be made aware of it if it is your mistake, if it's your branch. And this is done through like Slack notifications, for instance, or whatever communication you're using. It should be very transparent and obvious the health of the pipeline at any point in time. And the failures need to be fixed pronto, because like I said, you are preventing other developers from using the pipeline because the thing that you've got is stuck. And that needs to be fixed before going forward. So if the build pipeline, I'm going to use the word build pipeline a lot here. If the build pipeline fails, if there's an issue with that needs to be addressed quickly. Okay, that needs to be addressed quickly. And again, I'm not going to use the whole, wearing a silly hat or whatever. If it is your responsibility, I mean, yeah, okay, that's a bit fun perhaps, but to be honest, it's your responsibility as the developer who committed that change. But it's, to be fair, everybody's responsibility to keep an eye on that pipeline and to see if that pipeline is in a healthy state or not, and then to raise the issues if possible. And again, with things like Slack integration and stuff, that becomes, incredibly transparent. So that's a really good way. What I've done in the past, I've had like Slack channels dedicated to the status of the builds going through. And point number 10, before we get into how I'm using CI, point number 10 is don't confuse CI with CD. This is often people get tripped up by this. Isn't continual integration integrating the code into the main line, which is stable and therefore deliverable, right? So one point of continual delivery is that the code should always be constantly in a deliverable state. That is not true with continual integration. Continual integration is that you're integrating your code into into the source control. That doesn't mean that the code that you've committed is in a deliverable state. It just means that it is working well within the source control. There is often things in between CI and CD which prevent CD from happening. So with continual we shouldn't be talking about continual delivery because this isn't a continual delivery episode. Maybe we should talk about that. Have an episode dedicated to it in the future. But with CD, like I said, everything needs to be in a deliverable state, or the code needs to be in a deliverable state continually. But the thing is that trips people up there is the manual intervention. So once you've completed your feature and you've integrated it, and you can see the tests that your code test, the automated tests, you then need to do something to that to turn that into like a release candidate. Now, normally, in my experience at least, there is some user actions that need to happen there. So, for example, you could have a bunch of PRs that are all in a ready state, and the pipeline, the continual integration pipeline, could all be green, tick, tick, tick on all of those things, and then a user would, an actual human being would then do a pull request, or not a pull request, sorry, merge the pull requests in to a specific release branch, and then push that, or if it goes into main or master or what have you, or if it gets tagged after that, depending on what you do. But there's often a manual process, and also the biggest manual process that I didn't mention is testing, right? So yes, we test our code. Yes, we've got unit tests that say that things work okay. Yes, we may even go as far as having some automated acceptance tests or integration tests, and fine, that's all good. But often or not, there needs to be an actual human being looking at the screen to say whether or not this thing is working well. And again, I don't really want to talk too much about continual delivery, but really continual delivery shouldn't take more than, like, from CI to CD, from commit to deployment and release, shouldn't really take any more than a couple of hours. But that can be tricky when you're actually using manual testing, right? Because with manual testing, you also have to take into account regression testing as well, where you're actually testing the whole system. Like, say for example, you have a well-tested application, and one of the features that has happened, that's come through, is that you're upgrading PHP from like PHP 5.6 to PHP 7.4 or 7.4 to 8. One thing that I would certainly suggest is a level of regression testing. Now that is probably going to take more than 2 hours, right? So that's blown the whole CI/CD sort of thing out the water already, because of that level of strict testing. And that, in my opinion, is a good thing to do, you know. And also, a lot of these tests take time, right? Even the automated ones. For instance, the database tests, the integration tests, the acceptance tests, they take time because you're actually creating an automated test that mimics an action on the system. So whether they're clicking buttons and going into certain pages and filling out certain forms and all of that stuff, and then you have to reset the database at every step, every test, because you want to get it to a known, a repeatable place. I mean, that all takes time. So CD is something that is that I haven't done a lot on. I've done it before, but I haven't done it a lot on. And usually when I've done it, it's usually on testing environments, so staging environments and stuff. So you commit the code, and then that automatically gets deployed, because it goes through the CI and everything's fine, and then it goes through continual delivery, and then that is suddenly on the staging box. Very different though on production, because at that point it's then handed over to the manual testers before they verify that change can then go off to production. So I mean, it's very different for every shop, right? It's very different for every project. I'm just giving you a snippet of the things that I've experienced. Now, let's talk about how to code well. They are the 10. I'll just give you a quick recap of those 10. So number 1, CI should take no more than 10 minutes. Reverting changes, number 2, should also take no more than 10 minutes. Number 3 is to use TDD if where possible. Number 4 is to keep your commits small and simple. Number 5 is to monitor the pipeline. Number 6 is not to leave broken builds in the pipeline. So don't go on a lunch break, don't go to the loo, don't go home when you've set the build pipeline to run. Number 7 is to run the pipeline locally first before executing that. Number 8 is to keep the branches up to date, so keep your feature branches up to date. Number 9 is that failures should be addressed immediately. And number 10 is to not to confuse CI with CD. Okay. So that's all the good things, right? That's all the good practice, shall we say. Let's now talk about how I do it. So in the last episode, we were talking about the difference between self-managed and self-hosted services. And one of the services that I'm looking to perhaps purchase and have it as a managed service perhaps is CI. And I've used all sorts of tools such as Circle CI, such as Travis, such as GitHub, and more recently GitLab. I've used GitLab before in previously on different projects, but that's always been set up for me. So I've not had to work around GitLab runners or anything like that. So I've just assumed that everything works, and it has done, and it's great. But more recently, what I've been doing is using GitLab or trying GitLab out for the How to Code Well stuff. And it's very interesting comparing this to, say, GitHub Actions to GitLab. And I'll probably talk about that in more detail in another episode because I have some thoughts on why I prefer one than the other. I've only been creating my runners, my GitLab runners, for the past week and a bit. So I'm still quite new to it. But really, it's so far. I mean, you could probably tell where I'm going with which one I prefer. So far, it's going really well because I can mimic I'll just say it, because I can mimic the actual actions of the pipeline locally on a one-to-one basis, because I have the GitLab runner installed locally and I'm using GitLab.com as to see the pipeline visually in a dashboard sense. So how am I doing it though? How does this all work? So what I've done so far, and this is like very early days, really early days, like super early days, like this will change in the next couple of weeks, right? But right now, what I've got is whenever you push a branch, whenever you push to your feature branch, right? So let's say I write some code and I commit that and I push it up to GitLab. What I've got at the moment is that PHP CBF runs. So that's his a code beautifier. That will fail if there's anything that CBF can fix manually or automatically, I should say. So if that fails, then I have to then run that locally and then commit the changes that CBF has found. Then after that, it's PHP CS because CBF won't fix all of the things that PHP CS has found, CS being code sniffer. So this is like code sniffing here. Then after that, PHP stan. Then after that, PHP mess detection. Then after that, PHP unit. All of that takes around about 5 minutes-ish, which is fine. And that is my quote-unquote CI. So this is where I'm making sure that my code will integrate well with the main line. Then after that, I have something else. So I've split this into two sort of ways. So the second thing is around merge requests. Notice I'm saying merge requests, not pull requests, because now we're in the GitLab space. So this is a little bit more involved because this is where I'm requesting a merge of the feature into the main line. So the first one was just pushing to a branch. This one is now merging or requesting a merge from one branch to another branch. So for example, from my feature branch to the main branch. This does some more in-depth things. So we already know that CS, stan, mess detection, and PHP unit have passed. So that's all well and good. Now it's time to get into some more interesting tests. So I mentioned earlier that database tests, integration tests, acceptance tests take longer. And this is where we're going to do those. So we've got PHP DB integration tests. I am using currently Codeception for all of this. So this is testing the database calls. So what happens here, I should tell you about the mechanics of all of this. So what happens here at this point is that Docker spins up. It spins up a database container and it spins up a web server. They connect the two over a network, and then we can run commands on the web server that hit the database and then verify the records in the database based on a series of fixtures based on a particular state of the database that gets rebuilt every time after each test. So we're always running from a known state. The database is always running from a known state, which means that I can have multiple states if I wanted to. Okay, so what happens there is that PHP integration tests run, and then what I have at the moment, which I'm thinking of changing, is that PHP unit runs but with code coverage. The reason why we're doing code coverage here is because I want to have an artifact that has the code coverage report. And that can take a little bit longer because you're having to do some things with Xdebug and all sorts of stuff for coverage reports. And I don't think that I need to have a coverage report for every single commit of a feature branch, right? I think at the point in which there is a request to merge, that is a good point to have a code coverage report. Likewise, it's a good point to do a database integration test. A lot of the commits to just a normal branch could be things that aren't actually related to code. They could be README files. They could be some configuration that is not even related to PHP, right? So it could be JavaScript. It could be HTML. It could be changing colors in the CSS file. So I don't think that I need to do a code coverage report for every one of those. I think that's a little bit OTT. And so I don't, there's no point. So doing it when I actually do the merge, I think is important, because I want to have a handle on how the code coverage is improving or getting worse over time. One thing that I haven't done, which I will do at the point of merge, is to run, or merge request, I should say, is to run Cypress acceptance testing. So before we were using Selenium, but Selenium is so slow. Cypress is far faster. I haven't wired this up yet because there's a lot to do in order configuration in terms of Docker and everything to get Cypress running. I can run Cypress locally using the Cypress GUI, right? And I can run the Cypress tests locally. But what I would like to do is hand that off to the pipeline. And I want to do that on a merge request to make sure that the previous acceptance criteria is still being met. And at the moment, not including the Cypress stuff, at the moment, the PHP code coverage and the PHP database integration tests, they're taking roughly 7 to 15 minutes. It really depends. Sometimes it takes longer. Sometimes it takes shorter. I don't know why. I have no idea why. Let's just say 15 minutes. Just to be very on the top end. 15 minutes. The shortest I've seen it is 7. So this is why I don't want this to run every time I do a push, right? This is why I've split out the difference between a push to a feature branch and then a merge from a feature branch into another branch. That's why I've split them off. And in time, what we're going to do is probably have other levels of testing and other levels of reporting as well. So performance testing, security testing, all sorts of other levels of testing and different things that come out of it. So that's how I'm doing it at the moment. And I'm playing around with GitLab at the moment because I'm finding that very useful. GitLab, having that running locally, having the open source GitLab runners running locally. It's even making me think that perhaps we need to get something in this office that will be constantly on, and then have some of these jobs working at given times, because you can schedule these jobs as well in GitLab, which would be pretty awesome. And I'm starting to think that GitLab is actually a good replacement for things like Jenkins at this stage. But like I said, I've only been playing with it for about a week, so we'll see. And this is just evening work, so this isn't like going at it constantly. So it's early days. Maybe we'll do something on a live stream where I'm configuring one of these runners and playing with that. But it would be, I can see in the not so distant future me having a box in this office that is just dedicated to a GitLab runner. And if I decide against GitLab, I'll just install Jenkins on it or something. But so that's where I'm at. That is the continual integration, and they were the 10 points there. I hope this has helped. If anybody is totally confused by what I've just been talking about for the past however long, then let me know in the comments section below. I have probably mispronounced something or said something wrong, because I'm going to try and do this all in one take like a live show. Anyway, on Monday, that is the next time I'm doing a stream, and that will be on Twitch at about 3 p.m. And that's because we have a bank holiday Monday. So I'm not doing it on the Sunday, I'm doing it on the Monday, and we're going to cover, hopefully, the final 4 lessons of the PHP login course. So I'm hopefully going to build that there. Thank you ever so much for watching. If you haven't done so already, please do subscribe to both the podcast, so podcast on Spotify or iTunes or whatnot, but of course here on YouTube as well. Happy coding, everyone. Have a great week. Speak to you soon. Cheers. Bye-bye.